All right. I would like to start the evening, and I want to welcome everybody on today's webinar. Our today's webinar is about API security. My name is Tristan Rickman, and today I would like to introduce you to two speakers we have. Today we have Sunil Dutt and Erik Peeters, and they will both be talking about API security. The following is on the agenda. We will start with a short video from our president, Brenda, and then a short video from one of our sponsors. We won't be able to do our events without our sponsors, so we're very grateful we have them. The first speaker, Sunil, will talk with us about API security, how it is achieved, in his presentation called API Security 101. Our second speaker, Erik, will talk with us about API security in real life and will show us some case studies in his presentation, API Security in the World, Insights from the Field. The event will take about 2 hours, and you will receive 2 CPE points, which will be submitted by us directly to IEC Squared. We will start the meeting with Brenda.
Welcome, my name is Brenda. This evening we will be hosting our second online webinar, and we will have some great speakers, I'm sure of this. We is the Dutch IEC Squared chapter, and I will wish you a very pleasant evening and of course be awesome to each other. Till next time.
Thank you very much, Brenda, and thank you, Montalban, for making this event possible. As mentioned, we have 2 speakers, Sunil and Erik. At the end of each presentation, also during the presentation, if the presenter would like, it's possible to ask questions and they may be answered at any time. You will be able to ask any questions in the chat or in the Q&A section. Please also specify who the question is for, especially the end, because the questions may be between the different people. So no, I would like to welcome you, and maybe you can introduce yourself and start taking over the screen share.
Absolutely, absolutely. Thank you very much. And it's a great pleasure to be here tonight. Good evening, everybody, and goedenavond, want ik spreek ook Nederlands, but we're going to continue in English. So let me just start by sharing my screen. If you could maybe stop sharing.
You should be able to take over.
There we go. Here we go. All right. So yeah, let me just introduce myself. So my name is Sunil Dutt. I've been with Salt Security now for a bit over 7 months. Been in this wonderful space of cybersecurity for over 20 years. And obviously, I'm now very passionate about this very relevant topic of API security. And I'll gladly tell you a little bit more about why this is relevant today and what we're seeing in the wild and how you can protect yourself from these very advanced threats that we are encountering in the wild today. So let me just put this in slideshow mode and I'll start to share my story with you. So you can see the tagline right here, never worry about your APIs again. And I guess, you know, the question that is raised in the minds of many of you is, well, why should you be worried about your APIs in the first place? And that's a very valid question to ask. And there's actually a very simple answer to that question. Because the simple answer is APIs are nowadays all over the place. Many of the customers that we talk to have embarked on their own version of digital transformation. A lot of it got accelerated actually door COVID-19. Some of it got stalled and are now embarking on their own version of digitalization. But what it all comes down to is that everybody is nowadays consuming a lot of cloud technology, utilizing a lot of microservices. Obviously, there's already a lot of software present, and they are now starting to tie these components together. Making so that they can actually exchange information with each other. And that's where the true innovation really happens. And in that whole software-defined infrastructure, the APIs obviously are key to facilitate that. Because if you look at what an API does, an application programming interface, if you really look at the purpose of an API, it is to expose information, it is to expose data so that various components like cloud, microservices, and software can actually talk to each other and exchange data and information. So this is a wonderful thing. It's really driving a lot of innovation for our customers. But we all know as a community that everywhere where data and information is being exposed, you will have some bad actors that are trying to get access to that information for their own personal benefit. And unfortunately, that's exactly what we've seen over the course of the past year, particularly. This is the typical horror slide. I'm not going to double click on each and every scenario here, but there is a story to tell here. And that is that, big logos that are investing a lot of time, money, resources in cybersecurity to keep their logos out of the news actually made the front pages over the course of last year. And these are all examples of, very close to us, just across the border in Germany, Belgium. Here are a couple that you see from across Europe. And if you really double click on the anatomy of those breaches, you will 9 out of 10 times see that it was due to leaky APIs. This wasn't really a complete surprise to us because I think everybody's here familiar with Gartner. And Gartner already back in 2017 made a prediction that from 2022, so basically now, the APIs would become the most frequently attacked and abused attack vector moving forward. And this is a very bold statement to make, right? Because we're always used to the endpoint being the most frequently abused attack vector. And what Gartner was actually capable to do, and you'll see it here in the next quote, on December 6th, 2021, Gartner was actually able to statistically prove and show that there was a massive shift happening in the mindset of the hacker. They were no longer attacking the end user, they were now starting to attack the developer more. And we already saw that not only from 2022, but already from 2021, we saw a massive increase in the amount of API-based breaches happening. So the big question obviously is, okay, then why is this all of a sudden happening? What changed in the world that's driving this behavior from the hacker to all of a sudden shift their attention? Well, a couple of things. Well, first of all, the traditional endpoint that we're all using nowadays is better protected with great software. The user is actually also better educated on what links to click on and what not to click on. At least that's what we hope. But in this world of APIs, there has been some fundamental changes as well. Because if you look at the world previously, you see that APIs were actually represented in very few numbers, and they did not have access to sensitive data. So from an attack surface perspective, APIs were actually not that interesting to a hacker. But if you look at the world today with all the digitalization that has been going on, you see that APIs are now represented in hundreds, maybe even thousands. And these are also now participating actively to the overall IT lifecycle management, being patched and updated and being actively managed by a team as well. And APIs nowadays have a ton of sensitive information flowing over them, personal identifiable information of all sorts, right? If you just grab your mobile device and you just look at your banking applications or the way that hospitals are exchanging patient files and information with doctors and with patients themselves, etc., there are tons of examples where you can think of where all of this information is being transitioned from a cloud application to an on-prem or being utilized through a microservice. So the combination of this exponentially growing attack surface combined with access to sensitive data, that all of a sudden makes this into a perfect attack surface for a hacker to shift their attention towards. And
can I just, interrupt you? But on
sure.
the
Absolutely.
right side of your screen, there are some blocks in the middle of the presentation. I don't know why they appear there, but that's better. Thank you.
Oh, there we go. All right. That was the Zoom box. Let me just remove it. Here we go. So thanks for that. So there has been a second significant change in the world of APIs, and that has to do with the sophistication of the attack. And many of you have been around for a very long time and probably remember the evolution that endpoint actually went through. I still remember it clearly. 15, 20 years ago, I was working for a big endpoint vendor, security vendor, which was called Symantec. And I remember that our biggest competitor was McAfee, and our biggest worry was the I love you virus. And look at the complexity of the attacks that we are seeing on an endpoint level today. And we're actually seeing the same evolution on an API level as well. Because if you look at the world previously, a lot of the attacks on an API level were the known attacks, signature-based, maybe an SQL injection. It's what we call the one and done attack. Through a single piece of traffic, in this case, an API call, the hacker would try to get malware across to the other side. And often customers would have a technology like a web application firewall, or maybe even an API gateway that could do deep packet inspection, actually see the malware and block the traffic. Nothing too sophisticated, fairly simple. But if you look at the world today, with all that digitalization that has been happening, you see that the complexity of the attacks are also increasing. And it has an explanation. It has to do with the fact that many of these APIs nowadays are developed in-house. So that means that a hacker simply cannot use any other hack that happened across the world as a blueprint to understand how to penetrate the defenses of this specific API, because they're so unique to this one customer. So what does the hacker need to do? They need to invest a lot of time in what we call reconnaissance. This can take days, weeks. We've seen examples of more than a year where they launch what we call a low and slow attack. So the hacker tries to mimic an authentic sequence of API calls to kind of mimic authentic traffic, so they can bypass the defenses like the WAF or the API gateway and get the malware across to the other side. And what's also interesting to know is that these hackers actually come in pre-authenticated. And that's actually a pretty important notion, because we often think that applying authentication on our applications and APIs will protect unauthorized access. But we have a great example of literally 4.5 weeks ago, where there was a Spanish bank where the hacker just opened a bank account, requested access to internet banking legitimately, got credentials, logged in, had access to the entire internet banking environment, and could then take its time to launch a low and slow attack. And there are plenty of examples where hackers are actually acquiring and buying login credentials on various Telegram channels. So obviously, these new types of attacks and the advancements that hackers are making create some challenges. And these challenges, you need to address them with a new approach. And like every cybersecurity strategy, it always starts with having the right amount of visibility. Because what you cannot see, you simply cannot protect. And once we have the dialogue with many of the customers that are dealing with this challenge, we see that a lot of organizations don't know how many APIs they actually have running in their environment, which is not strange, right? I mean, many organizations don't even know how many assets they have, let alone how many APIs. But if you don't have that visibility, then fundamentally, how would you know if you were already leaking or overexposing any sensitive information? Yeah, you simply wouldn't. So the way that you have to solve that is by applying a API security solution that can fully automate it and continuous do the discovery of all your APIs. And when I say all APIs, I mean external facing, in-house developed, anything like third-party APIs, and maybe even most importantly, what we call the shadow APIs that are still running in production, but have never been patched and updated and are basically a door wide open at the back. And from that moment, you can also start detecting if any of those APIs is already overexposing or leaking information. The second part you absolutely need to take care of is your runtime protection. Basically, all those APIs that you already have running in production. Because what would tell you today, what kind of tools or technologies would actually tell you today if any of those APIs are already being abused? And that's a tough question to answer. And the biggest example that some of you might have heard of is with Facebook, where Facebook had an API-based breach, and they found out after almost a year and a half that they leaked 15 million account details. It took them so long to detect it because they didn't have the right techniques and the knowledge in place to be able to detect the advanced attack that they were undergoing. And these advanced attacks are nowadays also documented in the OWASP API top 10. And those are particularly the ones that you need to look out for when you're thinking about protecting your runtime APIs. there is a way to do it. And this is actually the only way to do it. And that is to analyze a ton of traffic, a ton of information to fully understand and grasp what normal API traffic behavior should look like over all your APIs, all the users, all the subsequent endpoints. And if you want to create a baseline, obviously you can't just do it by analyzing traffic of a day or a week. You really need to grab traffic over a very long period of time to make a solid baseline. And one of the things that you don't want to do once you're doing all that number crunching and analytics is to install 20 servers on your premises and have a lot of compute that you need to maintain and update. It's not good for TCO, and it's also not scalable. So the best way to do this is using a cloud scale big data architecture that will be running in the back end that will do all the analytics for you and provide you only with the actionable information. And one of the benefits of having insight in so much traffic is that you become context aware. And what I mean with that is, normally we would look at individual packets of traffic. That is almost the same as looking at individual pictures and trying to find out if something is wrong in the picture. But what you're missing is the actual context, because if you put a whole bunch of pictures together and turn it into a movie, the context can actually tell you that something's happening that shouldn't be happening at all. And that's one of the benefits that it will provide you when you're context aware. The third element, and which is equally important, is the proactive security. And what I mean with that, it's more commonly known in the market as shift left. And that touches more the development phase of the APIs. Because what if we just take the pre-production API, and before you put it into production, let's expose it to all the threats that we've seen in the wild, including the OWASP API top 10. We'll apply our best practices to it as well. And based on that, we can give a report to the DevOps team or the DevSecOps team on where they need to harden the API before they put it into production, so you're actually safe from day one. So before I continue, I've done a lot of talking, and I see a couple of chats. Let me just check if there are any questions already. Feel free to ask them now. If not, I can move on with the rest of the presentation. All right. Let me check real quick. So I'm getting a question. So why are these attacks only starting in EU, bigger in the US? Yeah, so it's interesting that these attacks were actually, the majority of the attacks were actually launched in the US. But now, since I believe a year, we're seeing a lot of EU-based breaches as well with very big brands, like I mentioned in the slide. And indeed, Erik made a very good comment here that you need to have a 360 view camera in various positions to really know what's going on. That's absolutely, absolutely true. And that is actually a good segue to what I want to talk to you about in the next section. Because there are ton of use cases that you can think of for API security. But what's really interesting, and this is honestly the first time in my career that I encountered a situation where this doesn't only touch the security teams, it also touches the development teams. And it's exciting to get actually both teams into one room to debate this, because what we quite often see is that security teams have the assumption that developers are actually putting their APIs into production safely. While if you talk to the developers, they are actually assuming that the security teams are adding a layer of security to anything that they put into production. And that's exactly where the blind spot is getting created. And that's why it's so super important to address this matter with both teams and get in sync, because we're driving so much innovation right now through digitalization. It's becoming super important to address these topics as a unified team within the IT space. And you'll see that there are many, many use cases that all of a sudden you'll start discussing, because it's not only the discovery of all the shadow APIs that you don't have visibility about, it's also making sure in terms of compliance that you're not overexposing information. And if you have a breach, that you can actually navigate the infrastructure towards the point where you can find where data has been extracted, and that could potentially be the API. So a little bit from an architectural perspective, because, and I've mentioned Gartner a couple of times because Gartner is extremely vocal about API security. From a Gartner's perspective, API security as a topic really has to be a part of your overall cybersecurity strategy from 2022 moving onwards. And for that specific purpose, Gartner actually amended their reference architecture for API security. They added one more layer, which is called API discovery and protection. And this tells us a couple of things. Well, one, API security is not a product, right? It's not something that you can buy from the stores. It's not a product. It's actually a security strategy that has multiple technologies involved, multiple layers in the total stack. And what you actually also see here is that these technologies integrate with each other, and combined and with the integration, they can provide protection against the most advanced threats. So none of the technologies are here to replace each other. It's more to complement each other. So what does that look like, from an outcome perspective, and what are we dealing with exactly? And I mentioned the OWASP API security top 10 threats a couple of times. And these are the top 10 threats broken down, right? And if you look at the first one, the broken object level authorization, and I believe Erik will spend a little bit more time technically on this particular attack in the next section. The broken object level authorization, otherwise known also as the BOLA attack, is responsible for more than 40% of all the attacks that are happening on an API level. Because of the sheer complexity of the attack, you can see that traditional technologies by themselves are simply incapable of detecting and blocking these types of attacks. But once you start adding an API security solution to the stack that integrates with the inline technologies, you see that you can simply put all these boxes in green. That's the advancements that you're making by adding a type of technology that will offer protection against the most advanced threats. And obviously, everybody here is acquainted with Log4j and Spring4Shell. We've all heard about it. By adding API security to the total stack, you'll be able to detect these types of anomalies 2 weeks before they actually get a name in mainstream. Because we then can detect this as a simple code injection, which represents an API 8 attack to us. So let's talk a little bit about architecture. I mentioned context a couple of times, that context awareness is so super important. So if you take an API security solution, it's important that the solution is not inline, right? It's not a proxy. It actually captures all the traffic, all the API traffic from various points in your infrastructure. That can be a load balancer, an API gateway, microservices, Kubernetes containers, VMware hosts, whatever produces the API traffic. From that moment, you run the traffic through the AI-powered big data engine. And this will take you approximately 2 to 3 hours to then fully map out all the APIs that you have in your environment. So after a couple of hours, you have full visibility of what your API estate really looks like. The next step is then to run the traffic through the context engine. And this is where all the artificial intelligence, the machine learning kicks in, and where you're truly benefiting of that big data engine, because it will take you another 4 to 5 hours to then create that baseline that we so need to be able to detect those anomalies. So once you have a baseline of what normal traffic should look like, you can do 3 important things. So after the discovery phase, you immediately have visibility, and you can immediately see if any of those APIs is overexposing or leaking sensitive data. You can also immediately see if any attacks are ongoing, and obviously also work towards remediation. And you can also improve the overall API security posture, because you can now proactively pen test those APIs before putting them into production. So thank you for attending this part of the session, and hope you got to get a good sense of API security and what it all entails. And I'm more than happy to take any questions from the audience. And I already see some in the Q&A. So, well, this is a good question. Why can't you go with a WAF or an API gateway? So, Erik, I noticed that you are going to answer that one live. Could you maybe take this one?
Yeah, sure, and we'll come to that in the next part of the presentation also. And it has all to do with with how these appliances are built. So a WAF is more like a proxy-based solution that looks at individual packets and can take decisions, yes or no, based on that single packet. But as you will see when we look at those business logic-based attacks later in the presentation, you really need the context over a longer time. And that is not something that a WAF can cope with. They can at most keep some counter buckets to deal with some DDoS attacks, but they can't really correlate and contextualize the data that is there. And for these business logic based attacks, you really need big data analytics. So could a WAF do that? Not if it's just looking at individual packets. It would have to have a means to go to a big data analytics engines in the backend to do that. A WAF, however, can be a very good point of presence to do the blocking. If you have somewhere outside in a cloud a big data analytics that is discovering those breaches, well, you could use your WAF or your API gateway or maybe your firewall to block those attackers.
Yeah, thanks a lot, Erik. And I have a great question coming in from Ulbe Damen. He's saying, well, but APIs are running once in a 24 hours or once a week. How is that handled?
You mean that, if we look at API traffic, API as traffic is different. There's some API calls happen very frequently, some happen occasionally, but you will still be able to learn those APIs over time. For these that are less frequently used, it might take a little bit more time before you get enough variation in traffic to really learn how they are about. And that is very typical to a big data analytics engine. It gets smarter over time. So you can, in a high load traffic environment, you can very quickly do all the things. For these specific low running endpoints, it will take just a little bit more time to get to know them. But when they are abnormally high, getting abnormally high volumes of requests suddenly, that would also be automatically and very quickly noticed by a big data analytics engine.
Yeah. Great, thanks, Erik. So maybe, Erik, maybe this is actually a good segue into your section of this presentation, if that's okay.
Sure.
Yeah, so thank you, Sunil, for the presentation so far. I will take it over first. Just give me one moment. So thank you. As you already know, the next speaker will be Erik. Still, if there's any question for Sunil, please put them in the Q&A. Make sure you put in the speaker in your question so we know who the question is for, and we will try and answer them later on. So the next speaker, Erik. Erik will be talking with us about some API security case studies. So Erik, if you want to share your video and your screen, and you can take over the presentation.
Sure. The screen is visible.
Yeah.
I think I have that same problem with the Q&A.
It seems a bit small.
It is a bit small?
No, not full screen.
Okay, that's strange because I'm having it here shared on the big screen. Not sure how to fix that. Let me see if I can share the desktop screen instead. Is that better?
I see in the chat that other people find it fine, so I'm sure you can.
Okay, no problem. Okay, so yeah, never worry about your APIs again. So that's the tagline of Salt, the company I work with. But yeah, the point of the presentation today is to talk about API security in the wild and some insights we've seen. So we'll go over a couple of these OWASP API top 10 threats and give you some real examples that happened in the field. But before we dig into that, let's first start with a small part of history. So basically, what we've how applications used to be, traditional applications, is you had a client that was doing a request for an HTML page, And that request was sent to a web server. And on that web server, we had our web application running. That web application would fetch the data from a database. That data would get back to the web server. The web server would render a page in HTML, and that would be sent back to the client. So remember this very good, because this way of working is still the way that some web developers look at their world and how they create code for the client web applications. And that is actually where certain breaches start to happen. Because if we look at how the world looks today, well, basically what we see is that we have not only that computer anymore that's going to a web page, but we have our smartphone, which has the mobile apps that we install on it. We could go still with our web browser, but then we're running a web app in that web application in that browser. It could be IoT devices that are requesting things. So, and they're all using APIs. In this example on the screen, we're using REST APIs, but there's also different things like GraphQL and so on and so on. And then they typically end up on an API gateway. But even in lots of environments, we see that even an API gateway is not in place there. So the functionality of an API gateway is basically to manage and route that traffic to the correct backend services. So it's kind of like a load balancer proxy kind of thing for our APIs. So in the backend, we have now very often those microservices running, and they each do an individual little task. So you have, for example, here a payment microservice, an identity microservice where we do our logon and analytics, and so on and so on. So if you look at a web application nowadays, they can have hundreds of these small microservices, each doing a small piece of the puzzle, and it's the client web application that brings that all back together. So Sunil has already mentioned the OWASP API top 10. A lot of people are familiar with the OWASP top 10, which was the web variant of it. But since 2019, I believe, or 2017, I think 19, there is also an OWASP API top 10, which is basically focusing on the threats directly related to APIs. And Sunil already explained how APIs are expanding and that they are nowadays used for all kind of communication or data exchange. So yeah, indeed, 2019. So the number one of those attacks is what we call the BOLA attack, formerly known as the IDOR attack. Stands for Broken Object Level Authorization. And that is basically where a user tries to get data from other users. So it's an authenticated user. And remind that Sunil said, like, authentication is in place, but it is not a guarantee that you're safe, because actually 40 to 50% of all the attacks on API are the broken object level authorization, which is done by authenticated users that do register a bank account and then start to manipulate those API traffic. Broken authentication, where things are misconfigured or where certain things can be exposed or misused. Let's say, for example, you have a password reset functionality where that you could basically request for a new password, and that would send you an SMS. But if there is no limitation in how many attempts you could do, you could just simply guess the SMS code that is being sent and send as many requests to reset the password within the time that you're allowed to reset the password, which is very often a day or an hour, but sometimes even 15 minutes. But even that is enough to send enough traffic to guess that token that is being sent and to reset somebody else's password. Excessive data exposure, which relates really to the old-fashioned way of working, because it wasn't a problem when the data came back from the database in the web application on the web server, because there we could filter out what we show. But excessive data exposure is about sending too much data to the client and then do the filtering on the client side. Lack of resource and rate limiting, which can lead to DDoS attacks and other things. Broken function level authorization, where a user is allowed to do a get, but gets away with changing his API call into a delete. And then he could, for example, change the APIs. Mass assignment. Let's say we have an application where you are allowed to do an update of your personal information, and you can change your name, you can change your password, you can maybe change your phone number, things like that. But there's also a get request for that same functionality, and that might also show other things, like, for example, the balance on your account. But what if it's not really protected, that you can't use those other parameters in your update function? So what if you could just use that same functionality that you use to change your password to, for example, change the amount that is on your account? That could be possible. Security misconfigurations, where simply things are not up to standard and where they can be misused. Injection, code injection, like a Log4j, like an SQL injection, etc., etc. Improper asset management, and also insufficient logging and monitoring. So let's take some examples of the top 5 here and go a little bit deeper in what they are about. For example, the A1, the broken object level authorization, or BOLA attack. So on the left side, we see a legitimate query where we see a GET request. And in that GET request, we see a user ID, which ends in 55. We see there's also a cookie in that request, where we also see the user ID 55. And at the bottom, we see the response for that same user ID, and we get the information from that user, his name, John Smith, his email address, and his phone number. But what if the authorization is not mapping really well to the authentication? What if on the right side, our attacker would, in the GET request, change the user ID to somebody else's user ID? So he's authenticated, he has his cookie user ID, which allows him to do the query, but he's not supposed to get the data from, in our case, David Miller and his email address and his phone number. So that is where a BOLA attack could exist. And this is just one of the many forms of a BOLA attack. There are a lot of different ways that data can be manipulated, in a sense, to get data from users that you're not supposed to get. So how should an API protection solution deal with that? Well, it should learn that these two values on the left side are always the same, and it should notify you when that is the case. And it should be able to cycle back to the developers that there should be checks built in to properly protect those APIs. So let's go to a real life example. There was a BOLA attack on the Russian central bank, where transfers were made by just manipulating account ID parameters. So basically, somebody was able to send an undisclosed amount of funds via a fast payment server system vulnerability. Undisclosed amount, read, a hell lot of money. So the attacker, he obtained customer data through a vulnerability, and he looked at the data in debug mode. He logged in as a real client and did like a small transfer to test it out. And then before transferring the second one, well, he said like, okay, now I'm not going to send my own account ID, but I'm going to send somebody else's account ID, and let's see what happened. And apparently there, the authorization was not mapping well to the authentication, which happens very often. And why is that? Well, authentication is very often a task of the infrastructure team. It's done, for example, on the API gateway. But the authorization, which data can be accessed, is very often done by the developers in the development of the application itself. Well, if these teams don't talk very much to each other, and they're not aware of what one is doing and what is the other is doing, and they both think the other one is taking care of the problem, and the developer thinks, okay, I have an authenticated user, so that's enough for me. well, this is when these kind of things can happen. So the system allowed the transaction without properly verifying those account IDs. So basically, you have your request and your response, which in this case is not the actual bank example, but again, the example we saw on the previous slide. But this is the way it works. You simply change account IDs to somebody else's. And you could very easily test that yourself in an application. And you could just look at your own APIs or your own application and see where two parameters should actually match, and try changing one of the two in an API request and send that API request and see what happens. That's the way that attackers do it. And that's the way you could also verify that everything is okay. The A3, excessive data exposure. So remember, in the classic days, we were sending all the data back from the database query to the application. And in the application, we would filter what data we would send in our HTML page to the client. But now in our new situation, we're actually doing the REST API call from the client that is ending up on the microservice. The microserver service gives the data back. And when the data is sent back, there sometimes developers still use the same method where they are filtering out the data on the client side, but you've already sent it over. So an API protection solution should be able to identify and report where sensitive data exposure is happening, what sensitive data is being sent out. That is not always a bad thing, because the APIs are built to exchange that data, but at least you should have good visibility in your complete environment where sensitive data is exposed. And even furthermore, where maybe sensitive data can be requested and answered to, where there is no authentication in place. So an example of that one is what happened to TreeFun. And yeah, the name of the application says it itself. So it's an application to have some fun with three persons. Obviously, because of privacy reasons, there is a lot of users that want their privacy set in that application. And you can flag that on so that your photo or your location is not just shared to everybody, and you can really choose who to share it with and who not. But if you look at the traffic, then you see that in the get and the response that you see below, you see that it gives back the latitude, the birth date, the longitude, the username, but also the URL where the photograph can be found. And then there is somewhere hidden in that request that the privacy flag is set. And then on the client side, we don't show the picture and we don't show the location. But it's already on the wire. You can just see it simply on the Wireshark, what is there. Fun fact about that hack, somebody looked at it and saw that there was actually one of these locations was happening in the White House, also in the Supreme Court. It could be just somebody making fun of it and manipulating even those API calls, but maybe it was really coming from the White House. And given the time frame, my question to you is who you believe it was. Was it Melania or was it Donald? Sometimes there is multiple of these issues in one situation. Let's look at the Peloton breach. So Peloton is an application where you can basically track your cycling endeavors. So if you like cycling and you train a lot, you can have your workout details tracked by the Peloton application. And it all started out with an A2, our broken authentication. So prior to disclosing the vulnerability, for some of the APIs, there was no authentication in place. So basically, that means you could request that those different endpoints, and there were a couple of these APIs impacted, without the use of any username, password, security token whatsoever. You just could simply query them and see what's going on. So you could just request simply the workout details of anybody. On the left side, you see the request, and on the right side, you see the response with all the data that's coming back. No authentication in place, just request what you want. But it's not only the workout details, because if you want to request the workout details of somebody, you need his user ID. So there's also the user search API that didn't have any authentication, where you could simply search for that user on certain parameters and then get the data back with the user ID. So you could get his workout details. So then Peloton was informed about it, that there was an issue and there was no authentication in place. And they reacted quite rapidly by putting authentication as a mandatory for each API call. However, they didn't have the time to implement authorization at the object level very quickly. So what that means is that our A2 broken authentication became an A1 Ebola attack, because any authenticated user could still do all the calls for all the users because there's no authorization in place. Yes, you're authenticated. Yes, you're a logged on user, but you still have access to all the data. If somebody took very good attention on 3 slides back, you see that there was also an A3 where we give too much data back to the client. If you look at the right side in the response, you see that there is profile private value is set to true. But we have our location, our start time, our user ID, username, Peloton ID. So all the information is still coming back. However, that the profile was set to true. So that's also something they needed to fix. Lack of resource and rate limiting. Well, that can accomplish 2 things. It can make that an attacker can get the data that he requires a lot quicker, because he can ask for larger chunks of data. But it also could be a means to do a denial of service attack. Because we see, for example, here on the left side, there is a regular post where we are requesting for a max return of 250 pages and a page size of 250. But what if there is no limit set to this API? Maybe on the endpoint application, you can just select up to 100. But I've done it already a couple of times in a web shop when I found the list was not long enough. And you go to the URL, because often it's even just in the URL, and you make it a bigger value, you get a lot more back. But if you really abuse that, you could set something like 20,000 or 200,000 or 2 million, which could affect the performance of the API. Definitely if it's single-threaded, because then now everybody needs to wait till you get all your results. But you could actually bring it down. So an API protection solution should recognize what are the normal values here and see when they exceed the normal behavior. And that is just by learning how the regular users work and to look at those excesses. Also, here was an issue with, for example, the SoundCloud application. So SoundCloud is an application where you can store songs and other sounds, and then they can be retrieved. If you use the app, you could actually request 16 tracks in one given moment. But what the attacker or the researcher here saw is that, he could just pump up that number to 689 tracks in a single request. And as soon as he went to that high number, well, the service response went way slower for everybody, almost 9 times slower. So this is a successful DDoS attack that could be performed just by pumping up that number in the request, because nobody's checking the maximum limit at the backend. Number 5, the broken function level authorization. So basically, it could be that you're allowed to do a post, that you're allowed to do a get for certain queries. And that might be managed in the application itself. But what if you could just simply exchange a post for a delete? maybe while you're not authorized, this API will just go through and it will delete the data for which you request a delete. So an API protection solution should baseline the typical access patterns to see where people are using functionalities that are never used by regular users. It could be that it is a matter of authorization where an admin account would be able to do it, but not somebody else. But it could also be, 1 second, please. There was some background noise from my son. But it also could be that, that particular functionality for that particular endpoint was not even developed, but because of the framework that is being used, it allows to process that and it allows to do those things. So let's look at code injection. So code injection is something that you could say, well, we can do it with a classic signature-based solution like a WAF as well, because they are very good at catching the known unknowns. They're not so good at catching the unknown unknowns. So what does that mean? Well, for example, a known unknown is the SQL injection, or 1 = 1 that you could add. And that could give you back data from the database that's not supposed to get out. But at a very large past, that was an unknown unknown because nobody tried it before and nobody knew about it. And that is also something that could happen with other things. API protection solutions, they should be able to catch those unknown unknowns. And they shouldn't rely only or solely on signatures to catch those things. So they should have a proper baseline of the normal traffic so that you can see when there is changes made. An example of that is Log4j. When Log4j came out, well, that was a vulnerability that got a 10 score in severity. And it was a very dangerous one. It was one that spread a lot, and we saw a lot of attacks going on. We had a lot of people that were very nervous because they needed to update their systems. They needed to update their WAF solutions with the proper signatures, their firewalls, etc., to become not vulnerable. Well, as a matter of fact, SALT, which is a big data analytics system, which learns how the normal behavior is, could find out easily that somebody was messing with those requests. And we could recognize that in some cases of the examples as a parameter tampering, in other cases as a code injection attempt A8. So with a big data analytics infrastructure where you baseline the normal traffic of the API, you have a much better protection against those zero-day based attacks because you're able to stop those. And if we look at the classic examples of security, well, we see that if we look at those business object or those business level attacks like the API security top 10, that they're actually very poorly in dealing with those attacks. You see that here for the API 8, yes, indeed, the WAF and the API gateway can catch them, but only if they have the proper signature. You see that none of these solutions is able to do a broken object level authorization. Looking at the API swaggers on your API gateway maybe, or validating that is followed, well, that could only work for our broken level authorization, where we could say that there is no delete in the Swagger file, so we're not allowing a delete, so we can block that. But you see that there is either some partial results or no results at all, and you need big data analytics to solve this issue. If you would like to learn more on how you can solve that issue and how that SALT security, for example, deals with that, you can easily request for a demo on the website you see here. So I would like to open now the floor for some questions.
Yes, thank you, Erik. I don't know if there's any specific questions to Erik, but I do see quite a few questions coming in. What I wanted to suggest is I take over one more time, and both you and Sunil enable your webcam, and we can walk through the questions and see what we can answer. So give me just one moment.
First,
Um,
that's bizarre. I have an unable to start the video. Sorry about that. Never seen that happen with.
I've asked you to share your video. Maybe it works now.
Oh, okay. Yeah.
There we go.
Okay.
One of the questions that's coming in from Robin van Loon is, who is typically consuming the alert events produced by Salt? The security team or the development team? And how do they receive those events or alerts?
Well, there's actually two aspects of that. You have on the one hand, you have the events of the attacks itself, and they are typically handled by the security team because it's the security team that needs to take action on them. Okay, you could also configure the tool to automatically go block a user on your API gateway or on your firewall, but you could also just send it to a SIEM, and then a SOC analyst can look at the details and take action based on that. But there is also the aspect of improving that API security posture, where you basically have the data that is valuable to the developer to improve the API security posture. And that is up to the developer to fix that issue. That's not the security guy that's going to fix that. So we're actually looking at the both teams, and it depends a bit on the type of information that we're looking at, what is more valuable for who. But if we talk purely about runtime protection of APIs, that is more for the security team, because in the end, it's the CISO that is responsible if there is a breach happening, not the development team, although they might have caused the problem.
Thank you. Another question from Albert van der Heuvel. A SIEM solution can analyze multiple requests and combine recognized API attack patterns based on these requests. He wonders what the added value is from using Salt in this case.
So you could build in a SIEM things around logging that you see, and you could run correlation around that. And when you look at that correlation, you could stop certain attacks of APIs, but it never goes as deeply because a SIEM is more looking at log aggregation, and it's typically not looking at the full API traffic. So how would you, for example, be able to check or to detect that somebody changed a user ID in a query if you're not looking in the payload on the SIEM, unless you're going to send everything to the SIEM, and that might be very cumbersome to deal with. So there are some basic attacks existing in API. Typically, that goes to the more frequent and the easier ones that are more general purpose, but not really the one that go onto the business logic attack, because very often there's nothing built around that in the SIEM to correlate that data, and you need the big data analytics to learn the normal traffic to deal with it.
Yeah. Okay. And if you learn from production traffic, does this mean you will learn to ignore attacks if these occurred during the learning phase, or are there failures mechanisms to counter this?
Yeah, that's a question that you very often get in every solution that works with the learning phase and so on. And that would be the case with a classic WAF, where you, for example, would have to put an application in learning mode, and then it learns also the mistakes and sees that as a positive security type of thing. But the big data analytics platform of Salt works differently, in a sense that it's learning on the fly, and it's doing blocking and learning at the same time, which is necessary nowadays. Because if you have a solution that you need to put in learning mode and you have an agile development, guess what? You're always in learning mode because your applications are constantly changing. So you need something that adapts to the fly. And there's actually a good example of that. We have now a customer in South America which was under attack, and they asked us, "Hey, could you help?" And we've put Salt in between. And after a couple of hours, we did not only discover their complete API list, but we were also able to distinguish the bad traffic from the good traffic. Why is that? Because you have a couple of attackers that are doing attacks, but you have still 100,000s of regular users that use regular traffic. So you can easily see that it is really out of balance, and you can really start detecting those anomalies, even if they are happening in the learning phase.
You mentioned about that Salt is doing learned behavior from the traffic it's seeing, but I believe a WAF can also do that. A WAF can also learn from normal traffic and then determine if APIs are being attacked. So what is then the added value with Salt on top of it?
They're slowly getting there, but they will never be as deep as possible as that, unless they start building the big data analytics in the backend. For two reasons. Yeah, a lot of those WAF still do their learning on that positive learning principle. So they learn how an application works, and then they can see if somebody is doing it differently. But that is very cumbersome to maintain in an agile environment. And the other thing is that, yeah, the way they are set up is they're looking at individual packets and need to take decisions of individual packets. So as long as they don't build a big data analytics platform that is behind it, they will never be able to catch in depth those business logic attacks. Yes, they're working on it, but it will take a time.
Okay. There's a question from Bjorn. Are there API solutions with passwordless rolling security measures? So do we not? So we do not have public and shared key, but maybe third-party validator as a sort of MFA.
Then we're talking more about the authentication part of the APIs, I believe, and that is more a job for the API gateways. So a solution like Salt that is looking at business logic-based attacks, looks at API traffic, learns how the traffic works, learns where the anomalies are, maps that onto the OWASP API top 10, and detects that there are errors or that there are attacks going on. It doesn't really deal with that authentication. It can see that there are certain data exposures that don't have authentication in place, but it is not involved in the authentication itself. That's more of a job for the API gateway.
Okay, I see two more questions which Sunil is going to answer. You can pick them up, Sunil. You're on mute.
Well, that was a rookie mistake. So you have one of the questions from Robin van Loon. What kind of implementations options do you have available for Salt? So basically, we have two options. Like Erik mentioned, we capture all the traffic, and from that moment, you have two options with that traffic. You can either route it through our SaaS solution, and that will be full cloud-based. And obviously, that is not the preferred option for many of the customers that we are dealing with here in Europe. We're dealing with GDPR, compliancy, regulations, etc. So for that purpose, we have the option of installing a local Salt hybrid server. This can be a stateless VM or a Kubernetes container. And what that actually will do, it will take the API traffic and will translate it to API metadata. So completely anonymize it. And for instance, if we see a credit card number, it will be translated to 16 access. And then from that place, you are still GDPR compliant. Hope that answers the question, and feel free to add anything that I missed, Erik.
Yeah, no, I think that sums it well up. Yeah, what we could say is even if you don't put that hybrid server in place, we would do exactly the same in our cloud itself. So we anonymize that traffic, and we don't store any credit card details in our database because we don't need to. But yeah, if you have a regulation in place that it can't even leave your premise, you can move that functionality to the on-prem.
Okay. And how would you handle false positives, in particular if volumes of those grow?
Well, first of all, there is, because we do the big data analytics, there is a very low false positive rate because you have the context and you know what's normal. But there is an easy way in the solution where let's take the example where we say, okay, we have the user ID in the bearer token, and we have the user ID in the cookie, and the system learned that those should always be the same. There might be some rare exceptions where that is not the case. In most of the cases, we would also learn that because all the regular traffic would show that those two values are not the same. But if they are 99% of the time the same, and they're 1% of the time not the same, well, then maybe we would say, hey, this is something that needs to be flagged as an attack. Then you can just simply go to that call and say mark as legitimate. And then you fine-tune the learning where you tell the system, this is okay to happen. It would make you more vulnerable to polar attacks because people can now start changing those values, even in the cases where they should be the same. But that's the way you can deal with it.
Okay. I see one more question coming in. Is proper forensic handling of recorded data in place? For example, would the data uphold a case in court?
All the information around the attacker itself would be available. What would not be there is the sensitive data itself, because that would be masked by stars, and you could not show what data was actually being used, but you could show who the attacker is. You can pinpoint who the attacker is, and attackers can be correlated and pinpointed in different ways. They can be pinpointed by their IP address, or they could be pinpointed by a security token or a user ID, etc., etc.
Okay. And to be able to inspect the traffic, you also need, you do need encrypted data to be able to see the data. Where do you catch it?
That is indeed so. If you want to look at the data of the traffic, you need to have it in an unencrypted way, and we're not doing the decryption ourselves, so we need to pick it up somewhere where it is decrypted. That can be typically done easily on an API gateway by just creating a policy that copies that data, because an API gateway will always decrypt the data because it needs to take some actions on it. But you could also be, for example, on a load balancer where you have SSL offloading or decryption and re-encryption in place, or we could do it directly as a sidecar on the container platform itself. So there are several ways. There's over 50 integrations possible to capture that data in an unencrypted way. If it's end-to-end encrypted, then usually on the container platform itself there is a way out. But if it's actually encrypted in the application itself, well, that part of the data would be difficult to catch, but that still would in many cases not be an objection of installing a security tool like Salt. You would not just not be able to recognize some of those encrypted fields as being sensitive data just because they're encrypted, and they might not have a name that gives away what it is.
I don't see any more questions, so I think that was the end of the questions. So Erik and Sunil, I want to thank you very much for your insights in the topic. As from the chapter, we like to give events which people are very interested in. So we have just one poll, which we would like everybody to give the feedback to on what kind of topic they would like to see in the next events. So I shall start up the poll, and everybody should see this on the screen. So I guess that's quite a clear answer. We will see if in one of the next events we can cover the two topics which are now on the top. So cybersecurity driven by AI and changes to the WBNI NIST2 directive. So thank you very much for the input. And that will be the end of this event. So from the entire chapter, I would like to thank all the participants for joining the presentation today, and also again Erik and Sunil for the presentation, and our sponsors for making this possible. A quick summary of what they've spoken about. Sunil showed us the techniques and how we can secure API connections and what techniques are used. And Erik showed us a lot of examples where API security is used in a number of case studies. So thank you both for your contribution today. If any of the questions were left unanswered, I don't think that's the case, but if there are, we will try and answer them after the meeting. Again, I want to thank the sponsors. And the last thing I want to say, please keep an eye out on our newsletter on our website. For the next event in September, we want to do something special. So it will be posted on the website. You can see the link on the presentation. So that is it. Thank you very much. And we will see you next time. Bye-bye.
Thanks, everyone. Bye-bye.
Thanks, everyone. Bye-bye.